this is our geometry course. Today we'll see patterns and inductive reasoning. Inductive reasoning is reasoning that is based on patterns you observe. If you observe a pattern in a sequence, you can use inductive reasoning to tell what the next term in the sequence will be. As an example, you have example 1 here. It says, write the next two terms in each sequence. I'm going to change our color here for letter A. So the first one says, for example, 1 plus 1 is equal to 2, to find the sequence from 1 to 2. Then from 2 to 4, we can say that is 2 plus 2 is equal to 4. To find the next sequence, we can say 4 plus 3 is equal to 7. Look, we're finding a pattern. We are using this number and then adding a sequence here. 7 plus 4 is 11. We already found our pattern. 11 plus 5 is 16. And we have 16 plus 6 is equal to 22. So I need to find the other two numbers. The other two numbers would be the answer of my last sequence, 22, plus continuing the sequence, in this case 7, would be 29, and 29 plus 8, which is actually 37. That means that my answer for letter A would be 29 and 37. Letter B is a little bit simpler because you already know the days of the week. Monday, Tuesday, Wednesday, which are the 2 days that follow, would be Thursday and Friday. Then we have in letter C. In letter C, we have a sequence. We have a line. We have a line that crosses. We have the cross line and another line that crosses. And we also have another sequence, if we make it, would be a cross line that we had here, and we can cross one line here. That would be a sequence. Because of space, we're going to do the other one differently. Let's cross it. And I'll cross one here, so that I can cross the other one here. Okay, as you can see, we formed another sequence. Let's continue with the next exercise. Number 2 says, make a conjecture about the sum of the first 35 odd numbers. Use a calculator to verify your conjecture. So we have 1, that we know that 1 is equal to 1, that is actually equal to 1 to the square. If we add another odd number, 1 plus 3, this is actually equal to 4, that is 2 to the square. We're finding a pattern. Then if we have 1 plus 3 plus 5, this is actually equal to 9, which is 3 to the squared power. We found our pattern. That means that the 35th number would be 35 to the squared power. And if you evaluate this in your calculator, it would be 1,225 as an answer. Then it says, not all conjectures turn out to be true. You can prove that a conjecture is false by finding one counterexample. A counterexample to a conjecture is an example for which the conjecture is incorrect. And you have an example here. It says some products have 5 as a factor as shown in the figure. Make 2 conjectures based on these products, one that you believe in is true and one that you know is false, and you have the 2 examples here. Your answers may vary. The truth says that the product of 5 and any odd number is odd, and the false one says that the product of 5 and any number ends in 5. Let's continue with the next type of exercise. Okay, this will be the last 2 exercises that we're going to make for this topic. It says, find the pattern for each sequence. Use the pattern to show the next 2 terms. These are the first letters of words. In this case, is the first letter of the number 1, 2, 3, 4, 5, 6, 7, 8. The next numbers that follow would be 9 and 10, which are represented by N and T. And these are the first letters of the months of the year: January, February, March, April, May. We're missing June and July. Okay, with this, we're done with this topic. I hope you understand. Thank you for watching. And don't forget, math is magic.